Hey everyone, welcome back. Ready to dive in?
Always.
Today we're tackling something I think a lot of us have heard about, but maybe don't fully, grasp,
I hear you.
ADHD.
Yeah, it's a really common one, and it's definitely one of those things where people throw around the label kind of casually sometimes.
Totally, oh, I'm so ADHD, when they just mean they got distracted.
Right, exactly. And it really minimizes what can be a really challenging experience for people who actually live with it.
Yeah, absolutely. So we're going beyond those surface level descriptions today. We're talking about the actual science of what's going on in the brain with ADHD. And we've got two
Really fascinating.
really fascinating research papers to dig into.
Yeah, and they're dense, so get ready for a deep dive.
Seriously. Okay, so paper number 1. The lateral prefrontal cortex and selection inhibition in ADHD. Sounds pretty intense already.
A little bit, yeah, but we'll break it down. It's all about this specific part of the brain, the lateral prefrontal cortex, or LPFC. Think of it like
The brain's control center, right?
exactly. Attention, decision making, planning, even emotional regulation, it all kind of gets routed through the LPFC.
Wow. Okay, so what's going on there with ADHD? Is it just less active or something?
It's actually more nuanced than that. So this paper, it highlights how in ADHD, the LPFC doesn't just function a little differently. It impacts something called selection and inhibition in 4 key areas.
4 key areas. Okay, now you've got my attention. Hit me with it.
All right, so number 1 is motor control.
Okay, so movement.
Yeah. Ever notice how some people with ADHD might tap their foot or fidget or, blurt out answers?
Oh yeah, for sure.
That's the LPFC's difficulty with inhibiting those motor responses, like inaction. It's not a lack of trying to sit still, it's that the brain might need a little extra help hitting the brakes.
Fascinating. So it's like having a car with a supercharged engine but kind of iffy brakes.
Exactly. You're going to have to adjust your driving style a little bit.
I'd probably crash, honestly. Okay, so motor control. What's the second area?
Perceptual focus.
Okay, so tuning things out.
Exactly. With ADHD, the LPFC can struggle to filter out distractions, and it's like every conversation, every noise in the room is hitting you at full volume all the time.
Oh man, I can see how that would make it basically impossible to focus.
It's incredibly challenging. All right, so we've got those two. Motor control, focus. What about the emotional side of things?
Ooh, yeah, good point.
So that's our third area, emotional regulation. You know how some days you're just more sensitive to criticism or you get excited more easily than others?
Ooh, yes, tell me about it.
Well, imagine feeling those highs and lows even more intensely. It's like the emotional volume knob is permanently turned up. That gives you a sense of how the LPFC's differences can make emotional responses in ADHD just hit differently.
That makes a lot of sense. It's not just about being overdramatic. It's a fundamentally different way of processing emotions.
Exactly. And finally, we have memory selection. Now, this doesn't mean people with ADHD have bad memories. It's way more nuanced than that. It's just their brains sometimes find it harder to inhibit those irrelevant memories from popping up.
Okay, so that frustrating tip of the tongue feeling, where you know something, but you just can't quite recall it.
Exactly. That might happen more frequently in ADHD because of this difficulty filtering out all those extra memories.
So it's like having a supercomputer for a brain. But instead of just pulling up the one specific document you need, it's showing you every file, every draft, everything.
A perfect analogy. And that's what's so important about this research. It moves us away from viewing these ADHD traits as personal failings, as choices, and helps us see them more as outcomes of literally how the LPFC functions differently.
So understanding the brain, not blaming the individual, which I think leads to a really important question. Do these LPFC differences mean our ADHD brains sort of stuck that way forever? Thankfully, our second paper gives us a little bit of insight on that. They looked at adults who were actually diagnosed with ADHD as kids to see how their brains adapted over time. And here's where it's really cool. They divided the group into people with persistent ADHD, meaning their symptoms continued into adulthood, and those with remitted ADHD, so their symptoms faded over time. What did they find?
Well, it's really interesting. Adults with persistent ADHD, they showed less activity in some key brain regions, especially when they were doing tasks that required a lot of cognitive control.
So less activity in these areas might be a reason why they're still facing those ADHD challenges in adulthood.
Yeah.
What are those areas, by the way, and how do they connect back to that whole LPFC thing we were talking about?
Great question. These areas, think of them as the LPFC's close allies. They're all part of the brain's executive control network, if you will. So if the LPFC is the conductor, these areas are the section leaders. They help to fine-tune decisions, prioritize info, regulate those impulses, all that good stuff.
So if those section leaders aren't as active, it's like the whole orchestra might be a little out of sync.
Exactly. And remember how we talked about the LPFC's impact on motor control, focus, and emotional regulation? Well, guess what? These areas, they play a crucial role in coordinating those functions.
So less activity in those areas could be why some people continue to have those challenges. But wait, there's hope, right? I mean, you said that some people's ADHD symptoms remitted. What's the deal with that?
That's where it gets really, really interesting. The study, it found that the adults who experienced what they called symptom remission, their brain activity patterns were basically indistinguishable from the people who had never even been diagnosed with ADHD.
Wait, so you're saying their brains basically looked like those of people who never even had ADHD? That's kind of amazing.
Right, it is. It suggests that maybe the brain can change and adapt over time, and that ADHD isn't necessarily some fixed, unchanging thing.
So while some people might continue to, navigate persistent ADHD, others might actually see their symptoms fade as their brains continue to develop.
Potentially. And that's why early intervention and support are so important.
It could increase the likelihood of having that symptom remission. Okay, so we've talked about the inner workings of the ADHD brain, but I'm really curious about potential solutions. Our next source explores a really, really cool approach to enhancing focus and executive function in kids with ADHD. And this is where things get a little bit sci-fi, but stick with me. This paper is called A New Perspective on a Frequency-Specific Brain Training System, and it's all about brainwave training. Brainwave training, like you're telling me we can literally train our brains to be more focused.
It's not quite sci-fi, but it's getting there. So our brains are constantly producing electrical activity.
Right, like little lightning storms in our skulls. That's how brains work, yeah.
Exactly. And that activity, those are brain waves. They oscillate at different frequencies, and each frequency band is linked to different cognitive states.
Okay, so like a brainwave symphony, and depending on what song is playing, we're focused, we're relaxed, we're dreaming, that kind of thing.
You got it. So beta waves, for example, they're in this frequency range, about 12 to 30 hertz, and they're associated with focus, attention, active thinking.
So when we're in the zone, our brains are basically cranking out those beta waves.
Exactly. Now, imagine a system that can not only read those brain waves, but can also give you feedback on them in real time. That's the basis of this training.
Whoa, hold on. How do you even read brain waves?
Well, they use this portable EEG device. Like the things you see in sleep studies with the electrodes.
Yeah, okay, I get it. So it's reading your brain waves, but then what? How does that actually train your brain?
Okay, so the device is reading your brain waves, right? And then, this is the really cool part, it feeds that information back to you. It could be visual, like you see something on a screen, or it could be through sounds, like different tones or something.
Okay, so you can literally see or hear how your brain is doing, like moment to moment.
Exactly. It's almost like playing a video game where the controller is your brain.
I was just going to say, that sounds like it could be fun, actually. Way more engaging than just trying to force yourself to focus.
Right, because you're getting that immediate feedback. Like if you're focused and your beta waves are strong, you're rewarded in the game. But if your mind starts to wander and those beta waves drop, well, you might hit a roadblock or something.
So it's like training your brain to produce those focused beta waves through positive reinforcement.
You got it. And the idea is, over time, this can actually lead to more lasting changes in those brainwave patterns.
So even when you're not hooked up to the EEG, you're better able to focus. That's incredible.
The research is still emerging, but yeah, that's the goal. It's like going to the gym, but for your brain. You're strengthening those attention muscles.
I like that, strengthening those attention muscles. Okay, so this all sounds very promising, but does it actually work?
That's the million-dollar question, right? But the research so far is actually really promising. Our third source here, they did a study with a group of children with ADHD, and they had them use this frequency-specific cognitive training system, they call it FSCT, for 13 weeks.
Okay, 13 weeks, that's a decent amount of time. What'd they find?
So compared to the control group, the kids who used the FSCT system, they showed significant improvements.
In what specifically?
Well, not just in attention, which you might expect, but also in working memory and even mental flexibility.
Those are some of the core challenges that people with ADHD deal with every day. That's huge. But okay, I gotta ask, it's one thing to see results in a lab, but did these benefits actually translate into real life for these kids?
That's what you really want to know, right? And according to the study, yes. The parents of the kids using the FSCT system, they reported noticeable improvements, like in their kids' academic performance. And even more interesting, they saw changes in their behavior, both at home and at school.
Wow, so it wasn't just like a temporary boost in the lab, it was actually making a difference in their everyday lives. That's really impressive. But what about what was going on in their brains? Did the study actually show like neurological changes as a result of this training?
Oh, yeah, they actually measured that. One of the most, I think, compelling findings was that in the group using the FSCT, they saw an increase in beta wave activity
Where was that increase?
in the prefrontal cortex. You know that command center we were talking about earlier?
Right. The one that's like kind of all over the place in ADHD. So they're literally seeing the brain changing in response to this training, and those changes actually match up with the improvements in focus and attention. That's wild. This isn't about like fixing brains though, is it?
Huh? No, not at all. It's more about giving people new tools, new strategies to help their brain work differently, work better for them.
Yeah, I like that. So medication, therapy, those are still important, but this could be like another tool in the toolkit.
Exactly. And it could be a really valuable one for a lot of people. I mean, this technology, it's still pretty new.
Right? And like you said, the research is still emerging.
Exactly. But I mean, these early results, they're really exciting.
They are. It makes you wonder what else we might discover as we learn more about how the brain works.
Totally. And, it's not even just about ADHD, right? This research could totally change how we think about learning and attention for everyone.
It's true. Everyone's brain works a little differently. And if we can start to understand those differences, imagine the possibilities. Like what if we could tailor our schools, our workplaces, to better support those different ways of thinking and learning?
Right. What if we could design environments that work with our brains, not against them? That's a future I can get behind.
100%. Well, I think we've definitely given our listeners a lot to think about today. From the nuts and bolts of how the ADHD brain works to like the cutting edge of neuroscience and, the future of how we might even approach education and work.
It's been a fascinating deep dive.
It really has. And to our listeners, thank you so much for using your amazing brains to engage with us today. Make sure to check out the show notes for links to all the research we talked about, and we'll catch you next time for another deep dive. Remember to like this video, leave a comment, and subscribe to the Daniel David Allen YouTube channel, where RoboCast is posted every weekday. Until next time, stay curious and keep exploring.